Hi, so as promised, we are here about again with another set of project that is basically a demo project how you can do content based recommendation. So if you haven't seen the first video about building content based recommendation in TensorFlow, that's basically understanding how content based recommendation works. I will recommend you to check that first before jumping into it, and from this uh, videos and onward we'll building a strong foundation of recommendation in 20 or 30 videos, probably 20 or 25 videos. Each and every video will be a project of recommendation, and from content based we'll go to collaborative filtering both in R, Python, and in scikit-learn, like recommendation recommender lab in R and TensorFlow, and from understanding to productionized. So first we are using here NLTK for stop word and TF-IDF and all that NLP works basically. So in basically content based recommendation system, the major focus should be on your similarity measure. Okay, just right here, what is your major focus? Major focus, it's basically similarity measurement. Three types of similarity measurement. One is dot, another is cosine, and another is norm. Okay, each one has its own advantage and disadvantage. This is what first we'll import array NLTK. As you can also use different like from Google or other available NLP frameworks. First we'll downloading the data, and we are using cosine similarity in this case. So from scikit-learn metrics pairwise, you can also import other similarity metrics. I will show you how to do same thing with Pearson similarity and all that. So this is what your data looks like in a very brief. Each movie has a title, year, rated, whether it's rated or not, released, runtime, genre, director, writer, actor, plot, languages, country, awards, some posters which will be some image file, and many other things like IMDb ratings, durations, IMDb votes, IMDb types, tomato meter, tomato image, tomato rating, and all that. Okay, so as we are doing content based recommendation is the basic of this notebook, so we are not going to illustrate all the EDAs and all that, but in later sections we'll also show all the EDAs and how to become like build hybrid models and productionized models. So first thing, I have taken basically all the strings which I think is fit for content based recommendation system and contains here, because most of the case ratings and all that are part of collaborative filtering. So title, genre, director, actor, and plot, these 5 things have been chosen, which is I think basically a part of the contents of the thing. So these are the heads, as you can see, that Godfather as crime or drama, as director name, and all the actors name. So what first thing we're gonna do, you're gonna discarding the commas between the actor's name. As you can see here, the actor's name has name, surname, and commas in between, because the film has more than a single actor, and we are taking the first three names. So you can also change here for better performance. You can take the first four. Okay, probably if some film has only three, so for safe side. And in the second set, in general, you will make a list rather than this formatted shape. You will make a list of the same. So, and you are making every line, every word as lowercase, and then splitting in with respect to comma. And in case of director, you are doing the same. You are splitting in with respect to the gap, so that your director will have name, surname, and each name and surname will probably go as a separate word here. So as you can see that this is the data frame after the formatting. Now the next thing what you have to do is that we are gonna here replace in actor side the spaces, as we're just basically combining the name, first name and last name, so that the individual actor are treated as same, right? Like Team Robbins are same, so we'll just gonna combine the whole team and Robbins. That's what this line of code does. And in case of director, we just want to join. As you can see, this is a list of words. Basically each defines a single set of name of director, so we just want to join the directors. So this is what this line of code does. Just run this, and you can, if you just visualize what your transformed data frame has become. This is what your transformed data frame has become. So yes, I think I haven't run anything. So just run each and everything once again. Now if I see, this is what my transformed data frame will look like. As you can see, all the genres are in a list. Director's name have been combined for each director, and actors have we only include 4 actors, and this is what our plot string, which is the plot. Now the next thing for recommending, as we said that we need to measure the similarity between two titles. Like basically a movie is identified by its title here, and we against the title we need to combine all these strings basically in content based recommendation, that all these strings, and we need to measure the similarity between the strings, and based upon this similarity we will be providing the recommendation. This is the whole concept of providing recommendation using content based recommendation. So in that case, if you want to show this in your website, you can show that people movies that you have watched are also similar to this kind of movies. So what we need for this, we need keywords, right? So just make another column for this data frame which will be keywords, and in the keywords what we need to make each row of the plot. We will initiate the rec function or method of NLTK. So what this rec will do, by default it will uses the stopword, as you can see, the English stopwords from NLTK, and discard all the punctuations. So this r dot extract keywords from text, and we'll have to pass the text, and text is basically nothing but each of the plots. So it will extract all the words by passing the text. Then the next function is get word degrees, getting the dictionary and their scores basically. So how many words are there and how many words score, like count basically. And at the last, in keywords, we are just going to list the keys. We doesn't have to do anything with counts here. So what we are going to do is just gonna list all the keywords that we have found, and as the work is done, we just going to drop the plot column, right? So as you can see, then what we are doing, that we are setting the index of title, as this is the basis of our recommendation. We'll recommend based upon movie name, movie title. And if we now see the transformed version of our data frame, we can see that our genre has some crime and drama and all that. Directors have actors, we have 4 actors, same by the same combination that we have seen earlier, that combination of their first name and last name. And lastly, we have removed our plot. We have transformed basically our plot into a keyword set of keywords. Okay, now next what we have to do, that we have to combine all these 4 columns into a bag of words. Okay, so bag of words means what are the words that's basically situated in that title, upon which we'll calculate the similarity matrix, and upon which we'll give the recommendation, right? So make another column which is bag of words. In columns, we'll store all the columns. df dot columns will give you a list of column names. And now we don't need the directors here. As you can see, if your column name does not have directors, so we'll just combine all others, right? So as you can see here, crime, drama, then all other words that present in all these 4 columns has been combined in this bag of words. Basically it is combination of all the words that present in all these 4, and we just discard all the columns rather than this bag of words. So this bag of words is the representation of all the 4 columns that we need for measuring the similarity of content, right? Now first we need to count vectorizer for the NLP task. As you can see, top from sklearn feature extraction text, we have imported the count vectorizer. For those who are habituated with NLP, it's very familiar to you. For those who doesn't have a very fine knowledge or at all any knowledge of NLP, you don't have to worry about all this. It's just what we are going to do here, it's just we just initiate and generate the count matrix, as you can see here. So if you have any doubt regarding this, just go type count matrix. Probably we haven't run this. So as you can see that this is a sparse matrix, okay, with 5601 stored element in compressed sparse row format. So it's nothing but a matrix that represents all this bag of words, basically in vector form. And we have made the index, the title index, as our panda series. So if you can see the first 5 things will get the same thing as it's before. Now what we have to measure, we have to measure the cosine similarity between all this count matrix, like what we have stored. And if we just run the cosine similarity function, it will do that. So you can see that first cosine similarity is 1. This is nothing but just because we have the same word cosine similarity between the same element of first. So that principal diagonal of this matrix, which is basically probably just a second. As you can see, it's a 250 cross 250 shape. So each principal diagonal here, you will find will have a cosine similarity of 1. So we have got our cosine similarity matrix. Right now we have to make one function for recommendation. So recommendation function will take your title, and it will take the cosine similarity function that we have built, and will give you the recommendation. Right. So recommended movies is basically a list that we'll want to transfer. First we'll need to get the index. So we are matching the title with our indices. We have stored indices previously, and we'll from this command we probably will get the index of the movie. Then we will pass the cosine similarity function to that index. Will pass that index to this cosine similarity function, okay, so that we can store the scores from this 250 cross 250 matrix. Then we'll just need the top 10 indexes, right? And top 10 indexes will start from 1. Why from 1? Because the 0 index that we'll have, that will be the same. Like if you go here from 0 to 12, you will get Fargo here at the result, okay. So if you run the recommender here, you will get Fargo, right? Because the first one is Fargo, as we said that it will multiply it, like Fargo has the most similar content with Fargo itself. So we'll generated top 10 indexes, and at the last we'll just append the list and we'll returning the movies, right? And this is what our recommendations, if you just run. So this is how you will build a content based recommendation system. Thank you very much.